We are so back, guys. We are so back. Um, if you can't hear me, please let me know in chat. I'm a little too lazy to check. But, yeah, it's been like a year since I streamed last time or uploaded a video on YouTube, so, this should be fun. What I'm gonna be doing today is doing interview prep. I'm on this weird website called Code Signal. This is what they use nowadays to recruit. Wow, look who it is. June Juice. Why didn't I just say June? But anyway, I'm just doing leak code problems. And if I look that way, it's just because my monitor's over there and I like can't move it any closer because the wires are too short. But yes, things are going well. The coding interview season is happening now, and low-key not as prepped as I want to be, so we will be doing that now. What's up, Prince Baja on YouTube? So anyway, this is basically like LeetCode, except it's its own platform called Code Signal, and then the interviews that companies actually send you are sometimes also through Code Signal. So it's like, I have a bunch of code signals to do, and I figured it was best to practice their practice problems so I could get good on their test. Because a lot of companies seem to use it, and their questions are a little different than just normal LeetCode questions. So let's see. Given two strings, find the number of common characters between them. The output should be 3. There's one thing I forgot. I'm actually terrible at doing LeetCode on stream or while anyone is watching. But that is something I need to work on. Okay, so S1 common characters. So they both have 2 A's and 1 C. This seems like it could just be solved with like a hash map or a set. So we create a oh yeah, just make a set of the characters. Oh, but it needs to, the counts need to be right too. So yeah, it does need to be a hash map. So let me just think. All the best. Where are you applying? Many places. Literally just like anywhere I could find. There's like this GitHub page that has like a bunch of jobs. So I kind of just look at that every day and apply, and then practice also. But not all companies are out yet. Let's see. Create a hash map char to count for first string. Then second string. then loop through hash map. Loop through like one of the hash maps and find the min and add that to the count. This is min from both and add to count. This is probably a really roundabout way of doing it, but it's still O of n. So I'm just gonna start by doing this. What's name of that? This platform is called CodeSignal. It's like its own interview prep thing. But a lot of the coding assessments that they give, that companies give, are through this platform, so I figured I would just check it out. It's like, you have to create an account, but then if you go to like arcade.codesignal.com or something. Oh, and the GitHub page. Let's see. Let me put it in chat. That is the GitHub with everything in it. Oh, I did not mean to do that. Alright. S1 map equals boom. Let's actually do a default dict. Actually, no, let's not. And then... Can't we just use counter? What is that Python thing counter from? Also, let me try to share my whole... Actually, it might mess up. Python counter. Oh, it's collections.counter. Good. From collections. OMG. Hello, Yazzie. I can actually read code. This is so cursed. I swear the last time you came on the stream, you were like... What was that noise? Oh. Did we get an alert or something? Oh, let's go. The last time you came on the stream, you were also like, wow, I can actually read code. So, this is such a growth moment for you. I don't even know how to use counter. I just assume you do that. Okay, for... items... Also, if the music is too loud, let me know, besties. If K in S2 map, then we want to have a common, or let's just call it res. 0 common characters. Res plus equals min S1 map. K, or S2 map K, and then V. Return res. Let's see if this works. Yippee! Let's go. Yeah, so this is like the easy section of whatever the hell this is. Arcade. Something arcade. CodeSignal. But low-key, some of these were kind of difficult. I would say they're like mostly LeetCode easies, but like some are between easy and medium, I think. Is lucky. Ticket numbers usually consist of an even number of digits. A ticket number is considered lucky if the sum of the first half of the digits is equal to the sum of the second half. Given a ticket number n, determine if it's lucky or not. Usually consists of even number of digits. Does it guarantee that... Okay, it's saying it's gonna give us an even number digit. Ticket number n, determine if it's lucky or not. Well, the easy way is to make it a string. The harder way is to do the mod operation. Determine if it's if the sum of the first half of the digits is equal to the sum of the second half. Okay, I literally just did one of these problems where you have to like mod stuff to get the individual digits, and I'm pretty sure what we can do here is, the thing is, how do you tell you're halfway? I guess you could take, how do you tell how many digits are in a number? What are you trying to do? Can you... The question is asking. I'm basically trying to sum the first half of the number and the second half and see if they're equal. We might be able to just create like a postfix sum. And then once we figure out the length, we can like split it. So let me just try. So if we mod 1230, well, I'm using paper right now, but if we mod 1230 by 10, we're gonna get like 1, 2, 3. Well, we're gonna get 0, and that's the first digit. Then we're gonna divide by 10 and get 123. And then we repeat this again and again. Mod 10, because it's base 10, we're gonna get remainder 3. And you know, it keeps on going. So then we keep track of a like digit number to some prefix, or because then how would you get the, yeah, to some digit to some prefix. So like it would start with, let's just say we start with 1. 1 would be the sum is 0. 2 would be the sum is 3. 3, the sum would be 6. 4, the sum would be 7. R would eat this up. I've never coded in R, but I heard it's for like math. Math, data science, statistics, which I don't like. As you can see, I'm struggling to do these coding problems, which means I don't have a good understanding of math. Well, I thought I had a good understanding of math until I went to college, and like there's just some people at my school that are just cracked and are good at math, and then you realize you're not that good at math. The LeetCode type of math you don't want to be good at, cause like that means you're just a tryhard. Okay, so the postfix. So now we know the length equals 4. So then we could get the total sum is going to be calculated to equal 7, which is going to be the last index. I'm definitely overcomplicating this, but this is what we're going with. And then length divided by 2, the map of that, the value associated with that is going to be 3. So, and then we do total minus, 3 equals 4. So that would be false. So yeah. Let's do this. Well, let's see, when do we stop? While n is greater than 0, we really could have just done this the straight way. While n is greater than 0, let's do the prefix sum. And we will need let's just do a from collections import default dict and then default dict int. So that just makes everything 0. Get the digit. So the digit value is gonna be digit equals 1. Digit value me after learning MATLAB and R because I got into the quantitative bio. Hello, Shivam. What are you doing? You doing job? So, well, I'm doing things to get a job, but I do have a job. This is like the struggle of computer science. It's like you're always trying to get to the next thing. It's like I have an internship, but what's next year's internship? And then after that, what's the job? These are all questions that all come back to I need to practice LeetCode, unfortunately. Digit value is gonna be n odd 10 because base 10. And then we say n equals mod equals 10. Or that's 4. Yeah, that's floor division, so that's good. So then we increase the digit, or we say prefix some and we'll set the prefix sum of 0 equal to, oh wait, it'll already be 0, perfect. Prefix sum 1, prefix sum digit equals prefix sum digit minus 1 plus digit val. Yay! Then, once we have the number of oh wait, we got a digit plus equals 1. Once we have the number of digits, we do total equals prefix sum digit, and then first half equals prefix sum digit divided by 2. And then return first half equals total minus first half. This would be so epic if it worked. Why are you not a developer yet? I am a developer. Why? What? The question is, why didn't I start coding in kindergarten? Hoping this base... I fear that this base case is wrong. Okay, why did that not? Expected true. Your return value false. Why? Why? Quickly print the prefix and yeah, we only need the prefix low-key. Low-key, we only need the prefix. Digit. So it's gonna end on digit 4. Or maybe it ends on digit 5. Let's find out for sure. Yeah, it does end on digit 5. Okay. There we go. Let's go. We're so cracked. We're so cracked. We're so cracked. We're so cracked. You should start counting the hour of code they made us do in Scratch during elementary school. I blame hour of code for the CS market being oversaturated. Yeah, why did we have so many get kids involved in STEM initiatives when, like, in middle school and elementary school? That is the reason why the market is so bad right now. And we thought, they thought they were doing a service to us. No, we needed to gatekeep STEM. Some people are standing in a row in a park. There are trees between them, which cannot be moved. Your task is to, like, if the problems were like this, like the one I just had, like the two I just solved fairly quickly. If the problems were like this, and they used to be like that because, you know, the field was less competitive, I would have a job immediately. Immediately. Instead, to do all these hard problems. If this is too easy, I'm gonna switch to LeetCode because those tend to be harder. When being a woman in STEM isn't enough anymore, you actually have to be good. Bro. So true. Some people are standing in a row in a park. There are trees between them, which cannot be moved. Your task is to rearrange the people by their heights in non-descending order without moving the trees. People can be very tall. What? What the hell is the point of this? Is this a sorting question? I don't want to do that. Oh, what if I just sorted the array? The bad way of doing this is to keep track of where the negative ones are, sort the array, then insert the negative ones back into their spots. Is there a better way? Probably not unless I want to write my own sorting algorithm. And the solutions for these are somewhere. So I could look and see how someone else did it if I want to try again. Anything can be solved if you use enough if statements. True. Sad truth. Let's create a trees equals a set of, or we could just do a array for val in A, if val equals -1. Oh, we gotta enumerate. Enumerate. So we can get the index. If val equals -1, trees dot append index, and then we do trees dot pop val. Oh, it's gonna yell at me though, because you're not allowed to edit the array when you're iterating over it. So just make a new array and then don't append it. Only append it if the value does not equal -1. Now we have that for tree in trees. Res dot insert, I think it is. Insert tree. Insert tree -1. Why have I never had to insert into a list in Python? Insert 1. Okay, I think I did it right. Position element, yes. Return res. Oh shit, I forgot to sort it. Does that sort? What? Name index is not defined. You're right for that, you're right. You right. You right. 6 out of 6 passed. Let's see what the solution did. Oh wait, did I close that tab? That'd be so sad. I can just find it again though. Sort by height. Road signal. It's in my history. Bro, the person did it the exact same way I did it. That's crazy. That's crazy. I made it to level 7, guys. I'm exploring the waters. Oh wait, no, I didn't. Reverse in parentheses. Let's just finish this. Let's just grind this one out and then proud of you. And then we could do an actual leak code problem, which will take me way longer. Write a function that reverses characters in possibly nested parentheses in the input string. What do you mean by that? Input strings will always be well formed with matching parentheses. Oh, great. So we should ignore the parentheses? Input string, the output should be RAB. For the output should be... Ooh. Oh, you only are the reverse the ones in there. Okay. Okay, I get it. I get it. This seems like a pointy pointer problem. Oh shoot. But there's this example. Foo. Oh lord. Oh lord. Oh lord. Baz. So if it's in parentheses, it's like its own unit of measure. I don't know how the hell I'm gonna do this. Wait, but why wouldn't that... So Baz goes over here. B-A-R-Z-A-B, okay. Oh. Oh, okay. Never mind. This makes sense. I think we need, like... Whenever there's parentheses, there's usually a stack involved, but then again, I've only seen, like, one problem with parentheses. This is probably some weird-ass pointer problem. Thinking about it in a stack way. So we could have a stack. Once we find a open parenthesis, we can add it to the stack. We probably want to add the... we probably just need to add the index. So in this case, the index would be 0, 1, 2. Let me just copy this. The index of the parenthesis would be 0, 1, 2, 3. 3. Then we would only start reversing in once we found like the end. Once we found an end. So we would go to this parenthesis here, add that on, so that 3, 4, 5, 6, 7. But that would be on top because it's a stack. Then we would find this guy over here, which is a closing. So we would pop off the stack. Stack becomes, 3. Now we have 7 here, and we can reverse from 7, reverse. Why do I keep doing that? Reverse 7 to, wherever we're at. So it would be like I, whatever, I minus 1 or something. So we reverse Baz. Oh, this is so good. I'm so goated. I'm so goated, guys. So this is the algorithm. I fear this is the algorithm. Anyway, then we get to this one. We pop this guy off the stack. Stack is nothing now. Then we reverse from 3 to whatever. Yeah, this is it. This is it. So we need a 4 I in range len put string a stack. You can just use an array as a stack, which represents the indexes of open parentheses. If input string I equals parentheses, we want to add it to the stack. If input string I equals this, closing parenthesis, reverse logic. Otherwise, we want to do nothing. Pop from stack. Stack index equals stack, not pop. Reverse logic, so let's just reverse it in place for the fun of it. 4 or let's do L in range index to I. Temp equals input string I. Ooh, is it gonna let me modify the string while I'm iterating over it? Definitely not. Definitely not. Python, would you allow me to do such a thing? Hmm. Yeah, I say we just create a copy of it. It might let me modify the values, but not modify the length. So for L in range index, but strings are immutable, right? Yeah, strings are immutable, so it's gonna create a new copy. Let's just try it. Input string. And then we do input string R equals temp. So that should reverse it. Oh wait, but we gotta increase L, decrease R. Then we once we reverse it, we just continue on with our day. Reverse object, blah blah blah. Expected an indented block. Oh, you're so right. Why did I not indent anything? Runtime error. String item. String order does not support item assignment. Bro, what? But I'm trying to get the char. Can I not get the char that way? Wow, it actually won't let you. Don't modify strings. Work with them as lists. Turn them into strings only when needed. Okay. Bet. I'll turn this into a list then. But the problem is still going to persist. What we need is like some other string. No, this is not gonna work. So once we find the thing, how do we reverse it? I mean, it should allow us to reverse it if we turn it into a string. Input string list. If input string I equals blah blah blah, if and the same holds true. Yeah, I don't think it'll yell at me. So the only problem here is we need to get rid of the parentheses. Like, let's just print input string. It's gonna be join. Input string. What? Input. Oh. Your return value undefined. That's crazy. Empty. Empty. Oh, error. Oh, wait. Input string equals list. Input string. Input string. L equals index. No, this should be index plus 1. R equals R minus 1. Okay, good. Then we just want to filter out so that should filter out the bad values. It literally did not. Val for val in input string if val and val. Yay! So Python string comprehension or list comprehension is wild. Like, if you come from any programming language and you see this, you're probably like, what the hell? Probably like, what is this? Witchcraft. Where are the semicolons? There are no semicolons, it's just English. Submit. We'd love your feedback. No, absolutely not. Is it telling me how long it took me to solve it? You made it next level. Like, why would, like, who is gonna tweet about that? That's crazy. Personally, I would not tweet about me moving on to the next level in the CodeSignal platform. God, there's so many different lessons. It's like, this is not even the, like, are these any harder? Return the sum of its digits. Like, this is not even harder, though. Plus n. Oh. This is literally what we just did. You unlock Squire. What the hell does that mean? What does it mean? You're a champ. Only 11% of users have solved this question. Who are the users in question? I don't know anyone who uses this. Cliffs of Pain. What? Alright, I'm done with this. I'm done. We are going to LeetCode. The actual LeetCode website. Crazy. Let's just change my screen though. Instead of a window, let's do application. Let's do Arc. Oh, well, that is my stream info. Why is it? Will it please tell me it's showing the other Arc? Okay, it's not showing the other Arc. It's so great. Sure. I guess I just have to share my whole screen. Why is it being weird? Like, why is it showing only that display? Not the technical difficulty. Oh, because I didn't have it selected to the right display. Window. Application. Okay. So it is working. Now we can just go to decode.io. Yeah. Yeah, I've completed all of arrays and hashing and also 1D DP, by the way. Let's try some sliding window. Sliding window maximum is hard. Should I attempt a hard on stream? Should I? What about two-pointer? Two-sum input arrays. I don't even remember how to do three-sum. Should I like go back and see if I've learned anything throughout this amazing LeetCode experience? I just remember this one being like terribly painful. Sliding window. I've almost done all of those, but perhaps one more from NeetCode.all. The maximum number of flips to make the binary. Minimum size subarray. Final k closest. Find k closest elements. Let's try this one. For no particular reason. Count subarrays where max element appears at least k times. You are given an integer array nums and a positive integer k. Return the number of subarrays where the maximum element of nums appears at least k times in that sum. Subarray. So it could be greater than k. Greater than or equal to k. And it has to be the maximum element. So I think we find the maximum first, right? We have to know the maximum to do this. So if we know the max, then the hard part is the at least, I feel. So we have 1, 3. Let me try to do this on stream. We have 1, 3, 2, 3, 3, and a k equal to 2. When we go sorry, I'm just blanking out for a second. So we start our sliding window at the first index, right? This is a sliding window problem. We know that the window is probably not a fixed window because yeah, it's definitely a variable sized window. So we need to check And the formula for a variable sized window. Let's see. Sliding window. I write notes for this, so this is what that is. Types of sliding window. Fixed window. Variable window. Window size is not fixed and can change based on certain conditions or criteria. Use L and R. Expand the window. Check a condition whether to expand the window. Process the window. Check if the window matches desired criteria. Okay, but this is the basic part of this problem. The hard part is calculating the number, because right now, like, the number of subarrays here is 0 because it doesn't contain 3. The max is over here is 0 because it only has 1 3. Here is 0. Now this is 1. Now, if we're looking at this whole part of the array, there's actually 2 subarrays that have at least k in the subarray, because these 2 3s are in this subarray, but they're also in this subarray. So how do we keep track of that? Perhaps we have to keep track of the Bruh, I did a problem just like this yesterday. The strat was like some prefix thing. You have a prefix thing that keeps track of like the current sum, but the current sum is not related, so maybe it's like the current number of elements of maxes in there. Current number of maxes is the key, and then the value is the frequency. Oh, so cur maxes to frequency. Yes, wait, this is all making sense. So like, for example, let's like, this will be our current maxes map. So like, we're gonna loop through the array at this position. The number of cur maxes is 0. So we know we have one value that has 0 cur maxes. Then yeah, 0 maxes. Then we move here. We have 1 max, so 1 goes there. And then we have 1 value with 1 max. let's see. 2. Wait, never mind, I'm confused again. We have 2. It's like when we reach 2, we want to do. So 2, 3, 3. Once we reach 2, we want to do cur minus k. So that would be, or max minus k. So 3 minus 2 equals 1. Oh, wait. 2? It could be 2 minus 2 is 0. And it would be the value at 0 plus 1 plus the value at 3. So at 2, we still only have 1 cur max. So this increases to 2. Here we have 2 cur maxes. We have 2 maxes, so once we do that, we have to go back and look at 2 minus k, which is 0 in this case, because cur is 2 and then minus 0. And then we look in the map and we get the number. And then we get 1 plus that 1 plus that number, and that will give us the value 2. Yeah. Okay. Let's try this. Prefix sum equals this. Number of max to frequency. And let's just, from collections, import default equals cur max, prefix sum, we have cur num. Let's just put this as target. Cur max. Since we have, so far we have 0 at 0. If num's I, equals target, else prefix cur maxes plus equals 1, and then prefix sum cur maxes so I like barely know what I'm doing here. Doing a data structures and algos course. Any pro tips? I am not a pro. Tips? I could give you some tips that there's no evidence to prove that they worked, but other than that, I feel like they worked. Well, if you don't know data structures and algorithms, that's like the first step. But like once you learn that, the hard part is determining how to solve these weird questions with those tools. The questions are like, well, the questions you're asking yourself are, how do you solve this problem? What data structures do I need to use? It's like usually you need to use more than one or more than one technique, but instead of just like memorizing the solutions to these problems, which I was pretty much doing in the beginning, I was focusing too much on the implementation and not on the patterns of the questions. So, for example, one thing that helped me, I feel, is like just writing down the patterns associated with sliding window. So like what it does. Oh wait, you can't see this page. Damn it. So essentially I have like a document with all of my notes for sliding window. And I break it down by topic. So I might put like the different types of sliding windows on that document, like a fixed window, meaning the window doesn't change size when you're iterating, a variable sized window. So if you're able to look at a problem and categorize it into a specific type of like a sub-problem of a topic, it's a lot easier to solve. This one is just hard, in my opinion, but other ones you can look at and be like, okay, like this is a sliding window problem, and it's a dynamic sliding window problem, so I'm gonna use this particular format that is usually used with sliding window problems. But you know, it doesn't always work out, and it's kind of just like picking up on those patterns is what you got to get used to. And I recommend doing a bunch of the same type of problems at once. Like for me, I only spend like in a session, this is not a typical session for me, but in a session I would only focus on sliding window if I was trying to learn sliding window. And I would do like tons of sliding window problems so I could really master it, instead of just like trying to remember things and then add to my document, try to see if there's patterns, because there's always patterns. And then like once you have your patterns or strategies for solving these problems, you could like just go through that list of patterns when you're solving a problem, and if none of them works, then you're screwed, but if one of them works, you got it. That is my advice. Definitely don't try to memorize it. Try to study it. Like, it's basically like a course in college, but a lot harder in my opinion, because there's so many possibilities with these questions. Prefix sum plus equals res if nums equals target. I feel like this is wrong. I fear this is all wrong. Let me go back to that problem what was it called? I know what it was called. No, I don't. Let me just go to LeetCode and look at the problem I did. My list. Oh no. Maybe progress? Maximum number of. No. What? Where is it? Oh, count number of nice subarrays. Yeah, it's very similar to this problem. Prefix sum equals that. Prefix sum 0 equals 1. Why is that 1? If for num and nums, cur sum equals cur sum plus num divided by 2. Okay, so let me go back to this. Cur max equals cur maxes. Well, that's essentially what this is doing. It's only adding 1 if nums is target. Then why is it not letting me go there? Oh wait, it's so similar that it looks. Oh, wait, no, it's not. Okay. Yeah, it seems like you really need to know which structures would be most effective for a solution rather than trying to memorize each algo. Yeah, yeah. Um, and just like there is a bit of memorization involved because you have to memorize the strategies to solve problems, but you don't memorize the problem solutions itself because like they all vary. Okay, I basically did that. If cur minus k in prefix sum, subarrays plus equals prefix sum that. Okay. If res plus equals, yeah, basically had that. I really need to understand this problem. Prefix sum equals prefix sum dot get cur sum 0 plus 1. Yeah, that's the same thing. Wrong answer! K goes 2, maybe this should be 1? Nope. Do I not use the default dict? Is that going to be the killer? Prefix sum equals prefix sum per I don't think this will help us. I think this is 0. But this one is correct. Why? This one is like the simple. Why does a 0 prefix sum have a frequency of 1 in this problem? Why is that base case there? Oh, this is at least. This is at least. Damn it. Damn it. Damn it. Uh, hmm. I have no idea how to solve this. Um, at least. I feel like this condition would change, but might just be a loop. And would that break everything? I'm gonna give up. I don't understand these problems well enough to attempt this, and it's just a waste of time. Okay.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, count subarrays where max element appears at least k times. I really like this problem because I completely misinterpreted it and solved a slightly different problem, but that slightly different problem was similar enough to this that I was able to correct my original solution to solve this problem.
Wait.
So I will
What if this was me? Like, cause my...
explain this solution in
Like, what if he said equals k?
array of nums. Let's take the first example. So this is our
Let me just try this. If for k in range k for action range k to 0 or 1 maybe, and then also go backwards. That did not work. Why is it the same? Oh. Eight. Wait. 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 No way. No way. No way. This is definitely gonna fail. Though. This can't be true. This can't be true, chat. It's taking forever. We're cooked. We're cooked. Yeah. 9 out of 633. Damn, back to the video. Back to the video.
say that k is equal to 2. We want to return the number of subarrays remember, this is like every single subarray starting at the first element, this is every single subarray starting at the second element, etc., etc. So there's n squared subarrays. So we should be able to at least brute force it with an n squared solution. But we want to return all the subarrays, and read this part carefully better than I did, where the maximum element appears at least k times in that subarray. And they don't mean the maximum in the subarray. They mean
Oh.
the maximum element of nums. So that's
Yeah.
Okay.
Our errors were different.
Question. So that's what tripped me up. I was dynamically keeping track of what that maximum number is as our subarray changes. But the problem is actually easier than that. So don't overcomplicate things, even though we just want the global max of nums. So if we keep track of the maximum number, we can actually just find that by running max on the input array. That's never going to change. So in this case, it's always going to be 3. If we're keeping track of what it is, it's 3 now. It's never going to change. It's always going to be 3. What this problem is asking in this example is how many subarrays do we have where 3 appears at least 2 times, right? That's what k is in this example. So now it becomes a little bit easier. Still, let's go along the brute force approach, because usually with array problems, brute forcing can give you a hint of how to solve the problem. So if we were starting from here, starting from 1, well, we want to keep track of how many occurrences of 3 we have. So let's call that the count. I'll call it CNT for short. Originally, it's 0. We have 1 so far. That's not 3, so count stays the same. Now we have a single occurrence of 3, and I'll mark that here. Now we still have a single occurrence of 3, and then when we add this element, we have 2 occurrences of 3. So we have a single array that we just counted. So let's say I'm keeping track of the result over here. We originally were at 0, but now we found at least 1 subarray. But we actually found more than 1 subarray, didn't we? This works, and this one also works, right? In other words, as soon as we find the kth occurrence of that element, what we really want to say is how many subarrays are ending at this position, right? Like that's kind of the intuition I'm getting at. But even if you can't figure it out, let's just continue to brute force it. Even if you can't make
How many
the solution of
arrays are ending there? Well, it's not just that, though. Ending there, but still having the count, because 2, 3 ends there, but then we lose out on the... so maybe, like, we have to keep track of this index somehow. So... yeah, but then it breaks down, I feel like.
Okay, that's 1 subarray we counted. Now I'm going to add another element over here, and that's 3. We found another subarray. But even if this wasn't 3, if this was 1, wouldn't we have also found another subarray? Like, we have 2 occurrences of 3. Adding more elements is going to always increase the number of subarrays, isn't it?
This has a bit of discrete math course in it.
Good to go. So that's another hint of every time we add an element, like here, with a valid window, we're really counting the number of subarrays that end at that element. And that's not super difficult. Let me show you how we can do it. First, let's go over a little bit of the intuition. This time, there is a 3 here. Now we have 3 occurrences of 3. So if we are counting the number of subarrays ending here, just like I kind of showed you here, like that would be this, and that would be this. We stop here because this is where our 3 is. We have exactly 2 3s in our window, and we need at least 2 3s. We can try shifting the pointer here. We can try eliminating this element, but then we run out of 3s, and we don't have enough. So we don't want to run into that case. And similarly, when we're counting the number of subarrays that end over here, we can do a similar thing. We can see that this window is valid, and so removing this value, we can see that this window is still valid. Removing this value, we can see this window is now still valid. We still have at least 2 occurrences of 3. Removing
Wow, that's a sliding window.
2, 3, and 4 windows ending at this element. Now, what's the pattern here? Because what I'm getting at this point is that this problem can be solved with a sliding window. I know I didn't completely go over the brute force solution, but if you do want to code up the brute force solution, I don't blame you because the intuition can help you arrive at the sliding window solution. Basically, the difference is with a brute force solution, we would be starting, let's say, at this element, and we would keep shifting the right pointer until we get to a valid window, and then we'd count all of those valid windows. In other words, we're counting the number of valid subarrays starting at this element. We would then rinse and repeat starting from here. It would require us to iterate over the entire array though, which is why it would end up being an n-squared solution, because we're going to do that for every single starting point. But if we invert our thinking, if we instead think about it from the perspective of
You can find a when you find a number, you know all subarrays of that number by doing position I 1 times n minus I. Yeah. So I guess you have to keep track of the point where like the window is invalid.
ending at a particular element, we can do the sliding window. Let me show that to you. So starting here, this is our left pointer so far. Then our right pointer is also going to be here. We're just counting how many 3s we have. That's all we're keeping track of. We go here, now we have 1 3. We go here, still 1 3. Go here, now we have 2 occurrences of 3. So I'm going to update our count, and it's now going to be 2. Now, at first, you might think that the solution is this. The solution is to keep shifting the left pointer until we can't shift it anymore, and that would be shifting it just once, right? We would say that, okay, this is a valid window, that counts as 1, then we shift the left pointer over here, and now this is also a valid window, but we can't shift it anymore. So in reality, we counted 2 valid windows. So now, let's keep going. Let's now take our right pointer from here and shift it to the last element. Now this window is also valid, which is what we expected, right? It's never going to become invalid now. We have at least 2 3s. Now we have 3 occurrences of 3. Now, if you're doing it the naive way, if you're saying, okay, this is a valid
Naive
window,
way.
+1, so I'm going to just mark the +1 over here, and I'm going to shift the pointer over here now. This is also a valid
But you're missing
window.
out on
Now,
3 2 3.
shift the left pointer so that it's pointing here. Sorry, it's getting a little bit messy. Now this is also a valid window, so +1 again. We can't shift the left pointer anymore, so now we stop. And we also realize that the right pointer ends at the ending of the array. So what did we do? We counted 5 subarrays, but the answer was 6. What did we miss? Let me replay that for you. When we got here, our left pointer is over here. But if this window is valid, of course, with 100% certainty, I know this window is also going to be valid. Adding
Oh wait, yeah, we missed that one.
a window invalid. So in reality, the solution is actually this. Don't increase the result as you shift the left pointer. Keep shifting the left pointer until it gets here. Like let's say in this case, the right pointer is here, left pointer is over here. So this is our valid window. And now is when we update the result. Now is when we say that where our left pointer stopped, the index would be 0, 1, 2, 3. It would be 3, right? The number of valid windows we have is going to be 3 plus 1. The left pointer plus 1. Because 1, 2, 3, 4. We're counting the subarrays ending at this value, and that extends all the way to the beginning of the array. It's always going to extend to the beginning of the array, because why not? We're trying to count all of the subarrays. At this step, what we would do is add a +4. And if I replay the beginning portion as well, you'll see it works there as well. We had our right pointer over here. This was our first valid window. We shift the left pointer until it's here, and this is, of course, index 1. So to the result, we're going to add 1 plus 1. So the result will then be set to 2, and that's because this is the valid window, and this is the valid window. So
Wait, what?
This step, okay, because why not? Add a plus 4. And if I replay the beginning portion as well, you'll see it works there as well. We had our right pointer over here. This was our first valid window. We shift the left pointer until it's here, and this is, of course, index 1. So to the result, we're going to add 1 plus 1. So the result will then be set to 2, and that's because
Oh, I hate this. So let's get rid of this. Target. Count. L equals 0. R equals 0. Wow. R is less than length. Nums. If check if I guess wait, didn't he say not to check it if it's there? I can't think right now. I can't think right now, chat. I'm logging off after this, chat. You can use a map to store all the arrays of a number. Wait, what? Map? You can use a map to store all the arrays of a number. How would that help though? Oh. All the valid arrays of a number?
with those couple variables, max number and max count, which is just going to be set to 0.
You want the maximum sum that appears number I. Number less. Wait, no, what? Maximum sum, huh? You want the maximum sum that appears. You're confusing me. Okay. Yeah, this is why I can't stream LeetCode. Okay, I did that. Bro, I was literally doing that. If I'm gonna use a while loop because I don't care. Watch. If nums r equals target count plus equals 1. Okay. is hard to explain by the computer. Nah, I get you, I get you. Honestly, when like someone tries to explain this to me, I don't get it. I need to figure it out myself.
In that case, let's update the max count by 1. Okay, now this part is a little bit confusing and there's a more concise way to write it, but for a beginner, I'm assuming that the more verbose way is going to be easier to understand because that's kind of how there's two cases. One case is where the max count is greater than k. In that case, of course, we want to shift our left pointer.
Okay. Max count is greater than k. Oh my god. Yeah, that is how you spell count. Okay, well, count is greater than k. Shift the left pointer, but also we need to like add to res. Res plus equals, what did you say? If nums L equals target,
want to minimize the window. So we're going to shift the left pointer, but also we want to update the max count. So if the number at the left pointer, nums at left, is equal to the max number, then decrement the max count. That's the case where we have too many occurrences of the max count. We're trying to shrink the window so that we can count the subarrays. The other case is we have exactly k occurrences of the max number, so max count is equal to k. But the value at the left pointer is not equal to the max number, so therefore the window can still be shrunk. So that would be if nums at
what?
value at the left pointer max decrement the max count. That's the case where we have
Or count equals k?
have too many occurrences of the max count number, so max the window so that we can count the subarrays. The other case is we have exactly k occurrences of the max number, so max count is equal to k. But the value at the left pointer is
Okay, max count greater than k. Max count equals k. I'm tripping. If it's greater than k, we shift left. If it's equal to k, we want to do like that weird formula thing, right?
not equal to the max number. So therefore the window can still be shrunk. So that would be if nums at left is not equal. To the max number. And the other thing before we can even check this is just to make sure that the left pointer stays in bounds, so it's less than or equal to right. This is the other case where we shrink our window. Again, there is a more concise way to write this, but conceptually it's just a little bit more complicated, so I just wanted to stick to this because again, that's
So this is just handling shrinking the window. We want to shrink the window until count is less than k, or until the window is like gone. Oh, window's gone and count equals k, and nums L does not equal target. Okay. Let's just get through this. I'm tripping. Okay. So then you do the weird formula, right? Res plus equals... What is it? The index of L plus 1.
This is over. Here, we have to check. Do we
We have to
this
check!
many K?
Kill myself. If count equals k.
And we'd always have exactly that many K, because if we had more, we would have shrunk the window, of course. So if this is the case, then we will update the result. We're going to update the result by adding to it the left pointer plus 1.
Let's go!
Let's run it to make sure that it works. As you can see on the left, yes it does. It's pretty efficient. I wanted to
Yes, it does. It's pretty efficient.
concise in case that is something you're interested in, because somebody always wants me to in the comments.
ChatGPT.
This example, consider if we change
A funny story about ChatGPT. Okay, this guy needs to stop talking. Funny story about ChatGPT and coding interviews. Time limit exceeded! Ah, I forgot to increment our... Ah. Okay. Funny story. Hello. Hello, girl. Hello. Funny story about coding interviews. During an actual interview, I pull up to this interview. It's like for an internship. It's like 3 interviews in like in one day. They're like 30 minutes each or something. 2 of them are leak code, 1 of them is talking, but it's still very technical talking. First leak code, okay, at this point, it's very early in the recruiting season, and I'm not that, and I haven't even gotten through all the topics to study for leak code. Like, I did not get to DP, I did not get to, yeah, essentially the big part of it was I didn't get to DP. So of course I get a DP problem. I don't know how to solve it's like it's coin change. It's literally coin change. It was so free, but I hadn't studied DP, so I wasn't gonna get the answer. Anyway, the guy interviewing me, like, is trying to help me through it. I'm struggling. This guy, we try to do it, but this guy can't seem to, like, get the correct answer. Like, he's putting in test cases, but they're not working. His code is not working. So, me and him are just trying to debug this code. At the beginning of this interview, he's like, you can look up syntax and stuff, but whatever you do, like, you cannot use ChatGPT or any AI things. I'm like, okay, whatever. That's pretty standard for interviews. As he's helping me debug him, this is a live code editor. I watch him Control A, highlight the entire script, paste it into ChatGPT, and I know that man was probably like, you know, what's wrong with this coin change code? And ChatGPT does nothing to help us. We're stuck debugging this problem. Coin change past the time the interview is supposed to be. And like we just can't figure it out. ChatGPT gave us no help. So yeah, this is why like, don't use ChatGPT for this stuff. The thing is, the solutions are online already. Like, the problem is not finding the solution. The problem is understanding the solution. Like, yeah, you could read the editorials here. You could ask ChatGPT what the solution is. ChatGPT is not going to help you better understand it. Usually it's reasoning. Like, if you ask it why for a particular line of code, it's probably going to give you an answer that, like, is not helpful at all. So the problem is understanding the solution, not getting the solution itself. That's why I don't use ChatGPT for that. Anyway, I'm gonna have to review this problem again. Granted, this is a different approach than what another solution had for a similar type of problem. So I'm gonna try to see if I can solve it this way, in that problem as well. But I'm gonna take a look at this. Thank you guys for joining the stream. This was a hard one though. This was a hard one, I feel like. Just counting subarrays is weird. I'm gonna have to like write notes on this because I've seen this come up a few times and I need to get them. But thank you guys for coming to stream. Had a fun time with y'all. Thank you for trying to help me with these problems. I'm just a little slow right now. But we did a lot of code signal. And, I am going back to school soon, so I'll probably not be streaming, to be honest. But I will try. I miss streaming, I miss YouTube. I haven't been streaming for a year or been posting on YouTube for a year. That was a long time. Today was the first day I'm back. And, yeah. I would like to do it more, but like my videos, I'm just so mad at the quality of my videos. And there's certain skills that I'm just like, I need to learn how to talk into the camera and all of these things. But I guess to learn that you have to make videos, and then it's like you have to edit the videos. It takes time. It's just, I always say if I had a video editor, I would post more, but I don't know if that's actually true. But anyway, I will probably be around. I have like 3 drafts for different videos. It's just I haven't gotten to recording them, and that is a huge part of it. And I have to edit it and all of these things. So, streaming is more accessible for me. But yeah, that's it. Thanks for joining stream, and see y'all later. You inspired me to get back to studying today with this, so thanks. Oh, that's nice to hear. Yeah. Keep up the grind, guys. Get LeetCoding, get your jobs. You know, the basic stuff. Bye!